Then so we are live in a sense.
Okay.
Yes. So welcome, Dario, to the podcast.
Yeah, thanks for having me.
Yes. Maybe you tell a bit about yourself. Who are you? What are you doing in Estonia?
No.
How you ended up here? Or it can
Yeah.
be a bit shorter introduction, but whatever you want to highlight. It doesn't have to be super short. It can be for 3 minutes, 5 minutes.
All right.
Yeah.
I'll start a timer.
Yeah.
I've been here for a very long time, actually. I think like permanently living 11 years. And then
11 years. Almost
yeah,
same for me. I lived 12 years in Estonia.
And before that, I spent 7 years coming here, like every chance I got.
Mm-hmm.
It's a land of opportunity, which is great. Not many of those left.
True.
It's also just really nice. Like people value quality here, which is
Mm-hmm.
good. And other than that, I've done software my entire life, software and languages, because it's the same thing to me.
Studied software?
No.
You studied languages.
No, I didn't study anything
Okay,
actually. I've never been to university.
Mm.
I did in Germany. You have this vocational training system where you just go to a company and work as an apprentice, basically.
You turned out okay. For not
Yeah,
going
yeah,
to
I think so too. I've been told it's not a complete disaster, and but yeah, like my first commercial software development was during the apprenticeship
in Germany.
in Germany in like 2011.
Mm-hmm.
Like mod Perl under Apache 1.3.
Oh wow!
Yeah. Fun times back when Ruby on Rails was new.
Mm-hmm.
And test-driven development was exotic,
Mm-hmm.
and Git was new actually.
Git was new,
yeah,
yeah.
Git was new. Like
Before
I
it
still work
was,
with SVN or like Subversion,
Mm-hmm.
and I did see CVS files.
Mm-hmm.
And,
I never worked with Subversion. I instantly started on Git.
yeah,
Because when I studied in university, Git was already a thing, and then I just started on Git. Yeah.
it's like nowadays I feel like. So the thing about Subversion is that having branches was extremely difficult.
Mm-hmm. Mm-hmm.
Which means the only way to develop was essentially to push straight to the main branch, because that's kind of like the only branch you had.
By the way, one thing I'm actually making a note is for us to discuss about the future of version control. That could be another 1 hour.
So yeah, so that, like looking at it from a fresh perspective, is I think a model that has a lot of benefits that we should employ more often, but aren't. The only problem with Subversion was that you had to check out and lock individual files. So it's like, oh, only Vitaly can touch that file. Like nobody else can touch it until he releases the lock. And that kind of made it be like dead in the water compared to Git. Git it is. I hope Git doesn't change.
But yeah, back to intro.
yeah, back to the intro. I mean, I felt like this is a nice
No, it was
segue
good.
into the first topic. But yeah, currently I work at AMP. We build a coding agent, like and unlike Claude Code and Cursor and Codex. So it's hard to pinpoint the differences. The best comparison I can make is that we do all of the hard work for you as much as we can. So with AMP, there is no model selector. Like when you go to Cursor, you have to choose from all of the models. We do that. We think about how are you going to use the product. We can do that because we use the product ourselves to develop the product. And for those different modalities, we provide the best choice in the given moment.
Like opinionated and calibrated, continuously calibrated experience.
We ship our opinions so that you can focus on your work instead of fiddling with models.
So recently, today, my Pactum colleague shared with me the article about AMP, because I said, look, I'll have podcast with Dario, what should I ask him? And he shared with me the article that the coding agent is dead, and it was published by AMP. So can you talk about it? What does it mean, and what's the AMP's vision of the future of software engineering?
Maybe before I go into that, like when you saw the headline, what did you imagine, or what did you think about?
Good question. I mean, I'm biased. I guess you meant about the form factor, or like what will be the interface of doing the work. So it's not going to be necessarily you open up your laptop and you start like prompting, hey, please do this. But maybe the interface gets more robust, more automation, or trigger points will be different. And of course that it doesn't happen in localhost, but in the cloud. So that's kind of few thoughts that...
That's basically it. I mean, last year...
Did I do TLDR?
No, it's almost as if you read the article already. Basically, last year we saw a lot of development in that area where like people were racing to build a coding agent. And that's mostly harness work, like what tools are available, how do these tools work, how do you work with the different models. And that is work that can be done at some point. And you do it, and then you're left with, okay, but what next? And the more we used those agents, the more we realized that, okay, maybe we're at the end of that path. Like this is, there are only so many things you can do. Like we experimented with a lot of tools.
At the end of which path? Just
building the harness. Like what are the tools available to the model? Like we experiment. Like do you need a to-do list tool? Do you need like long-lived ticketing system kind of
It's interesting because when I think about harness, I mostly think about my executable tests that provide feedback loop, or some kind of programmatic feedback loop that agent checks the work against.
Yeah.
So I mean, yeah. So but how do you think about harnesses?
So a model in itself can't do anything. It's just like, if I simplify a lot, it's text in, text out. You have the same problem that you have in every functional programming language. How do you actually do things? So the way to do things is that the model tells you, hey, I want you to run this test for me. And then you go and run the test and you tell the model, this is the result of running the test. And that's how we did it in the Stone Age with, like the old versions of ChatGPT or whatever, where there were no coding agents. The agents didn't have tools. And you had to do a lot of copy paste. And then what essentially happened is that now we have tool calling. The models are trained for tool calling, so that you have a program that reads this intention from the model. Hey, I want you to run the tests. That program actually deterministically then runs the test.
Okay,
and
so you mean actually detailed agentic harnesses to make sure that it does execute the full loop. Okay.
Yeah, that's so kind of like that's what we looked at as a decoding agent. And the other thing that happened last year was that the models got better. They got so good that you just didn't have to babysit them at every step anymore. Like there was very little value in keeping your eyes glued to the agent and interrupting it and steering it and doing all of these things.
And models themselves got better in tool calling and understanding.
And just general intelligence. Like like most of our initial prompts in team now are like 1, 2, maybe 3 paragraphs, depending on the problem. Like for simple things, it's literally you copy paste the email
Context
from the customer and into AMP, and then Torsten mentioned this on Twitter that he actually he figured, I was like, oh, am I the bottleneck? Like why am I sitting here and pasting bug reports from emails into AMP just to get the result and paste that back into the email? Like something is,
now
that can be automated away.
Agent is using human as a tool.
Yeah, exactly. And that's I think where things are headed next. Like, how do you build a system that can do all of these things for you? Because the models are so good now, and they will get better. Like even if they stopped at where they are today, there are like so many things that are not connected yet, where you have all of these bottlenecks that can be eliminated, that if you actually fully dedicated yourself to just building more harnesses, connecting agents to different things, you'd still be busy for a long time and get a lot of value out of these models. But that's not what's happening. They keep getting better. Like there is more training scheduled. We'll get new models. We just got Opus 4.7, so so they'll keep getting better. And I think it will become especially interesting from the perspective of harness engineering once we have extremely fast inference. So right now,
You mean first, like the time to first token or last token?
yeah, like Cerebras, or there was this, or this Canadian startup called Talas. They do a very crazy thing, which I think is like gets a bit lost in their demo. So when you check out their demo, they give you the normal LLM chat, but it's instant. Like it generates a page of more or less correct information.
What's again the name?
To your Talas, T-A-A-L-A-S. In the time it takes you to blink.
Yeah.
And you're like, wow, that's extremely fast. Such a shame that the model is so dumb. And turns out they did nothing fancy in a way. Their demo is just based on like Llama.
Yeah.
I think 31 billion parameters or something. Like it's just an open weight model that's.
But that's the future, right? Like all the smart models we have today, they'll get as fast. Just a question.
So what they do is they build hardware and software to build bespoke hardware for individual models. So you can take a model like Llama, dump it into Talas, and then like 2 months later, you get out Llama as a hardware chip that does Llama inference instantly.
Yeah.
And then, okay, the demo was Llama, but what if you use an actually like good model? And then you have like infinite instant inference on tap. And then the challenge is, what structure do you build so that you can actually
process all of this? Yeah. Because again, if comprehension and you are being the bottleneck, right? Like how do you deal with all
this? Exactly. This is at the point where you cannot realistically review anything. There's just so much of it. Like you might even have trouble with like running code you generate that way because it's just so much.
But sorry.
Then the question is also like, maybe you don't need code anymore.
Yeah.
Maybe you replace your business logic with an inline LLM call because it takes 10 milliseconds to generate the answer. And
I think in some sense, I mean, maybe it's simplified, but the bottleneck becomes, in terms of software engineering, becomes verifiability. And how do you develop testing harnesses to do that, right? Because pretty much in any kind of engineering life cycle, you have to check the assertions of the test. And then, like, this is the bottleneck, because once the assertions are there and you verify them, you as a human know they're correct because they represent the business logic or edge cases that you want. That's enough for the agent to go nuts and do like millions of feedback loops against it. But this is like I call it like golden labeling. Like this is like your labeling, which is expensive. But once you have it, and of course, if you have it on a system scale, then you can tell it like, port it to another, using it another library. So if you have end-to-end tests, or like all test harnesses, you can say, now don't use this library, but use that. And it will eventually get it.
Right? Yeah. And as you said, the hard part is actually codifying what you want.
Do you believe, by the way, this is interesting, I'm speculating now, but now our language for verifiability or tests, right, is the same as the language in which implementation is. Do you believe language science, and I mean programming language science and verifiability DSL will evolve over time? So it will be language agnostic, implementation language agnostic, but still be executable like it is today.
You can do that today already. Like nothing stands between you and doing that. If you follow Uncle Bob Martin, he writes a lot about that now, where he just brought back Gherkin files from behavior-driven development, and he just had the model generate a parser for those files, and everything he wants to express, he expresses through those.
But I think we're getting there, right? Where, I mean, the language should be specific, right? Because as we know, English language is not enough. It should be specific. So you can define all the constraints, inputs, outputs, constraints, given when then, pretty much, on all levels of abstraction. And then...
but defining your own languages or implementing your own languages is so cheap nowadays that you can just do that. I had one project where I just used HTML files because that's like, oh, it's like semantic markup, nice. Now let me describe my test cases. because that specific project was about re-implementing an existing programming language, but also with multiple runtimes. So I would always have a single test that I wanted to run against the original implementation, and then against 2 implementations in 2 different programming languages that are like hosts for my implementation. So every test had to be executable by 3 different runtimes. So ultimately, all the tests were just data. I chose HTML because there's already a script tag, it's a natural home for code. And then I captured interpreted state that I wanted to assert on. Like, is there an error value at the end of the evaluation run? Or is there a result value produced? Is there any output produced? That's all captured in those test files. And then I had the agent build a little test runner for me, which basically takes that file, extracts the code in the programming language I was implementing, takes that code, pipes it into the actual real interpreter, and asserts on the results, pipes it into my one implementation, and pipes it into the third implementation, and checks that all 3 line up. And highlights the differences, and
so
that's
high-level
how I could
test, feedback loop.
And that was completely like decoupled from the implementation, which also had the nice side effect that I could take my entire test suite and just run it in a browser. So that was really cool, because like for a programming language, it's good to have a lot of examples highlighting a lot of features, and then it's pretty nice if you can just go to the browser.
But the way I'm thinking about it is, it's interesting. So let's talk about testing strategy, because I think it is a very critical topic for now, like in terms of agentic development, because you can go as fast as you want. You can be Ferrari, but if you're in the traffic jam, which is like your bottleneck, the verifiability, you're stuck. But so what you said right now, you pretty much had end-to-end test, but the interface was, I don't know, either UI or public API of the output of the, let's say, your component. And that's why you can make it language agnostic, right? Because you either read STD out or REST API, whatever the interface is. But if we talk about the holistic testing strategy for engineering organizations today, and something that was true, let's say, 10 years ago. So what I mean is that I want to discuss, let's say, and this is anyway a controversial topic, like the classical testing pyramid, right? Like unit tests, integration tests, and end-to-end tests. And one school of thought is keep end-to-end tests thin and only focus on like some edge cases and heavy paths and be smart about it, but don't have them too fat. Then have a bit more integration tests, and then even more unit tests as you need. And of course, some people say, no, you should have like more integration tests, and then very thin amount of end-to-end and unit. And I mean, everything in between. Some people think actually it should be inverted. And of course, there are trade-offs involved, etc. What's your take on testing strategy nowadays? Has the economics and the feedback loops changed so much with agents that we have to rethink the testing strategy?
Absolutely. It also depends on the project and what phase of the project you're in. But the testing pyramid comes from basically a cost-benefit ratio. End-to-end tests are expensive to run, they're flaky, they're expensive to maintain, and that's why we want to have very few of them. However, they also give us the highest value signal. So now you need to look at them again, like, is the equation still correct? Like, are they still expensive to write? Are they still expensive to maintain? Are they still slow to run? Are they still flaky? And I think when you use agents in the right way, and maybe you don't follow testing orthodoxy in terms of like only one assertion per test, then a lot of these assumptions are just not true anymore. And you can make this even more interesting. I haven't seen much in that space, and I haven't like played around with it myself too much yet, but I keep coming back to this idea that you basically want an agentic tester. Because somebody who clicks through your product from morning till evening and reports issues.
Pretty much monitoring, agentic monitoring.
What we couldn't do in the past because
defining those
we had to like define. We ended up with scripted scenarios instead of like giving somebody an objective and the software and then having somebody execute that. But now with agents, you can just give them an objective. Here's a piece of software. I need you to use that piece of software to fulfill the following goal, and they will figure out what needs to be done to achieve that goal.
And they'll write a report on.
And they'll write a report for you, and then that's great, and that's what you want to have. However, it also means you need to adjust your production software. Like, you need to have a test user. Like, these are tests you run against production, because like it's just like another user in the system.
Yes.
And the, data setup is complicated and so on. You're well familiar with that. So, but I think that's something that's a bit underexplored at the moment, and it can help you find real bugs faster, or real friction. Maybe things work, but UX becomes easier to handle if you say, oh, there's this very common use case, and from all of the agent logs, we can see that it took like 10 clicks where we wanted to take 1 click, because this is a problem that every user has, or like an action every user performs.
But what you're saying is pretty much agentic tester, in your words, for me, is like monitoring on steroids with agents. But in terms of, if we talk about, let's say you're in the high stakes environment where everything before production should have very high level of confidence. And I mean, actually, this is true for most businesses, kind of. Depends. There's a spectrum. But let's say if we would talk about robust tests in your CI/CD pipeline, you would go with, let's say, well-defined end-to-end tests, right, as the cornerstone of safety nets before you roll to production.
Again, it depends on, like,
just
with my work at AMP, like my perspective has changed a bit, because you can actually do a simple test. Can you name a bug from Claude code from 6 months ago?
A bug?
Yeah.
I don't know.
Exactly.
Yeah.
Obviously,
I mean, the fact that it was down, but
yeah, but it's like there was no screw up, no bug that was so massive that you stopped using the product, or that you forgot it, or that you wouldn't forget about it.
Yeah. But of course, let's be honest, it's different. For example, I come from fintech, right?
Yeah.
And there are some domains where you cannot afford to make a bug because the outcomes are very bad, right?
Yeah, but like that's the thing. Like, you need to look at it through the like, what is the impact of messing things up, and that's very different based on the product area. If you cannot update your profile picture in your product, it's not critical. Like, it's more important that you can fix this within minutes of discovering it.
I agree. Mean time to recovery becomes important.
Yeah,
right?
yeah. So that's the like, the turnaround time is very, very important. But yes, of course, there are high stakes mistakes where, like Knight Capital style, if you have one.
I guess my point is,
condition.
I don't think that this augmented and agentic engineering is only relevant for people who can afford to go reckless. I think this transforms the unit economy of software, even for the high stakes companies. Right?
Absolutely. I mean, now you can do cool things like property testing and mutation testing and things like that much more easily, because with mutation testing, the idea is that you have something change your implementation, then rerun the test suite, and if the test suite still passes, you have a problem.
Yeah.
Because obviously the test suite didn't assert enough of the real behavior. And the difficult part about mutation testing is making the mutations. So you can just brute force it by just parsing the code and what happens if I flip the comparison operator in this if around?
Sometimes you need a domain knowledge.
Sometimes you need domain knowledge, exactly. So
like how to mutate to make
how to mutate,
feasible.
or create test setups that.
But that's where models get also smart, because they might understand it and infer how to mutate correctly.
Yeah. So you can just tell the model, change this code.
Go.
We want to see a failing test, and then it will change the code to something that's similar in spirit, but maybe has a different implementation or something that's slightly wrong. And then if you get a passing test suite, you know that your tests are not complete. So you can iterate on that, and you can automate that, and you can run it in a loop. Test suites are, they're a bit of a double-edged sword.
Automated test suites.
They're like a strong mold. So the more you write, the more you can be sure that you've asserted the shape of the system and the behavior of the system. But the more effort it becomes to change it later on.
Yeah.
So some areas don't change much. And that's where it pays to invest in such a strong foundation, or as I said, like high stakes changes. That's also where it pays to invest into like a very complete test suite. But there are also areas where the main value is just experimentation and seeing what works and doesn't work, and you wouldn't want to take that flexibility away by casting everything in stone.
Interesting thing, by the way, about TDD, and again, I know it's a religious topic, and well, I'll not be lying, like I've been proponent of TDD for a while, I've been practitioner for 10 years, but I really, well, I went back to the roots and read the books from Ken Beck, right, Extreme Programming and Test-Driven Development by Example. By the way, terrific book. Have you read it? He's bootstrapping like JUnit or like the testing framework by like using TDD. Which is
TDD is one of those things that I think you need to experience for it to make sense. Like if you don't give it an honest shot, then it's hard to get it.
Yes, it's hard to get it.
But once you've gotten the you're trying to trick yourself on both sides. You got that loop. It's a very reliable source of dopamine.
But why I'm mentioning it now, because I read, and I didn't expect honestly it from Cloud Code, but when I read the Pragmatic Engineer post where Boris shared how they work in Cloud Code, it struck me that he says he and his team is using TDD a lot now, and they see TDD renaissance. And in some sense, it makes sense because, again, now the only bottleneck is your skill. And for you to create a testing harness is very easy. Like, the only bottleneck is you prompting and, like, you understanding these harnesses. And anyway, through tests, you can make a design, right, and create those verification loops. But now, the interesting thing, I think that some people get wrong with TDD, especially those who haven't tried, you can exercise the red-green refactor loop on any level of abstraction that makes sense to you. So what I mean, and you can go fractal around it. Like you can start with an outer loop and then if needed, create smaller tests. So the way I approach development today in engineering is that whenever I need to implement, let's say, end-to-end use case, something, I will think about the biggest level of modules and interfaces, how I want to experience this use case or module. And I will start from an automated test, like maybe Happy Path in some edge cases, from that perspective.
Yeah.
Because this is like my main kind of design. This is the constraints that I know should be there. And then I have a decision to make. I can just tell to agent, look, this is my assertion, go verify. Oh, sorry, go implement. And this would be enough for me. Or I can go kind of fractally on the level lower and do the same for integration test or unit if I decide to do so, because my level of confidence, let's say, I know I have some very, let's say, financial specific logic or calculation, and I want to kind of create a separate boundary of it and create even more confidence level. I would kind of TDD inside it as well. And maybe other parts is just a glue code, and I know the end-to-end test will cover it, and I don't need to write any extra test. So I think this spectrum that it enables you is also interesting to consider. I don't know, just sharing.
Yeah, definitely. I haven't done TDD in a long time, like the actual TDD. And I started deleting more tests, like
because they were kind of a waste. They were like
no, they were useful in the moment, but like they helped the model figure out the right solution to that technical task. But then there's no point in like keeping them around, because the purpose of the test was not to forever cast behavior into stone. The purpose of the test was to assert things at runtime.
Yes.
Just like, okay, a faster way for the agent to try out the program, so to speak. But once you have enough confidence, you can delete the test.
What's your philosophy? And again, let's then wrap up the testing stuff. But it's still fascinating. I remember once in a while there was a conversation. Well, there's an epic conversation about TDD or not TDD with DHH and Uncle Bob. But there's one more, and this is about the constraint level programming in runtime versus tests. So and I forgot the name of the person, but the person who invented the technique. And the idea is that you verify inputs, outputs, and constraints of the component in runtime, as pretty much TLDR assertions in runtime. Are you? I'm honest, we are not exercising it, but it's a very interesting and compelling strategy as well.
So here's my unpopular opinion.
No, please. You can speak. I'll just check
I
something.
feel like static types are so overhyped to the point that people just stop experimenting with the alternative.
Right. Static types, you mean?
Yeah, like, I think my biggest gripe is with how people use TypeScript. Because the TypeScript compiler can do a lot of things. Like
infer a lot of things as well.
Yeah, like TypeScript types are Turing complete, so you can, you know, like there's this guy who wrote Doom in TypeScript types.
Yes.
So you can do a lot of things, and this attracts a lot of, like, if you believe in static types,
like doing unions and pick and those things.
That's like to some degree even still fine, but like like some libraries
I saw
have
people overdoing it.
Yeah, it's like people start fetishizing over those types and get lost in that. And the problem I have with that is you still need to check data at runtime. Like, I view static types more as like hints for the compiler to make the program run fast.
Yeah, especially data on the runtime on the edges of your program.
Yes.
On the inputs
So
and the external system.
It will never, like, static types will never be enough to assert all of the properties that you're interested in, because a lot of those properties only appear at runtime, like input data from the user.
And you need harnesses in the runtime.
So you need to deal with runtime errors anyway. And what I like to do in my pet projects, at least, is at the edges of the system always use something like Zod or Typebox or like some schema validation library.
We use Zod as well in Pakta.
Like religiously, that's the important part. And then if you have that in place, you get away without having static types.
Yeah. Oh my goodness, we're so much on the same page. But what do you think about, though, there's another school of thought exactly about the fact that, again, you don't trust the external outer world, right? You like verify religiously everything that comes into your system that you don't control, like religiously. And then the full notion of parse not validate, right?
I mean, that is that basically. Like Zod is parse not validate.
But I think that's important, right? The moment you have you know that you validated thing, that you embed it in a type or some new class or object, whatever you have, to kind of state that. Because the worst thing you can do is if in the domain layer you're like, I don't know if this is validated outside or not.
Exactly. And that's why I also like classes, because they're like data with a tag attached to it and behaviors attached to it. So you get a lot of the stuff for free, because, like, here's the thought experiment. Think of all the effort people put into static typing. How good would our runtime systems be if all of that effort went into things you can actually use at runtime?
By the way, I love both. I love types and runtime harnesses. And this is, by the way, why I don't like, though, let's say, current runtimes of TypeScript, because their runtime don't have type checks, right? So like you can have things nicely in a compile time, but your runtime will tell a different story. It's a bit different picture with like JVM languages or Go, right, where you have instant type check and like you will fail fast if things don't work. And it forces, like, why I say it's good, because it forces the mindset for engineers to make those checks on the outside, because they know like their program will panic if things don't match afterwards. But I wonder, what do you think about the TypeScript runtime today? I have a bet that the runtime of TypeScript will improve over time, because the industry will invest into it.
Again, I feel like TypeScript types they're too complicated, and then people invest so much into defining all of their types statically, and then they forget about the runtime stuff.
Yes.
And then it's like, what if you'd spent the same effort? And because technically you can lose the compilation step, which is a big win. And even if you end up with runtime type errors or whatever, they come out very fast in practice, and they're also super easy to fix when they come out in practice. And especially if you have parsing at the edges with stuff like Zod, in practice you will rarely run into type errors. And even with TypeScript, you do run into runtime type errors, because it's very common for people to just say, like, trust me, TypeScript,
Yes.
this object has that shape. And the second you have that in your code or in any of the libraries you're using, you're back to square one.
But okay, let's get out of the rabbit hole of types and testing.
Maybe
But
one
it was
experiment for you to run, like
Yes.
next time you start a project, even if it's just like a prototype, just tell the agent, always use Zod or whatever your favorite schema library is to validate data at the edges of the system.
No, I agree.
Write JS doc and don't use TypeScript. And do Ruby style object-oriented programming. And every time I do that, I don't get runtime errors. Like even with plain JavaScript.
It's interesting. Your position checks out with pretty much DHH view of that. But yeah.
I grew up in the Ruby world.
Okay.
Professionally.
Yeah, I grew up in the first C and then Java world, and then we had actually in Wise we had Java and Groovy, which were like two different things. And it was like, oh, okay, Groovy has this type inference and other things. But yeah, anyway, about maybe bunch of topics we might discuss, but maybe to start with the future, like where, and again, we started with that, but to continue, so maybe for me to wrap up and you can reflect on that, like what do we need for effective agent to do the job, right? I think you need a good context. That's where all the talks about context engineering and having good context. You need great tooling, right? Access to tools. And even more, you need I think not only access to tools, but you need the whole model about which tools are read-only, which are write-only, sometimes the permission model around it. Sometimes you need human in the loop, sometimes not. So you have all the harnesses around tooling. But now maybe let's discuss about the execution environment for agents and like, sandboxing agent or not, running agent in the cloud, exploring the environment. Because how we started, right, is running in the local host, running on your laptop.
Yeah.
What's your take on the future of environments where agents run?
So let's start maybe with the word sandbox.
Yes.
Because it has like
overloaded.
It's overloaded. Yeah. There's two very common meanings. One is like a straitjacket from like a security perspective, like a sandbox where everything can be controlled, and the other, maybe like more original version of the meaning is like it's a safe environment in which you can make mistakes, where you can play around.
This is my definition.
And that's getting a bit lost in the current discourse because everybody's obsessing about like restrictions and security capabilities, which, to be fair, I think
they kind of go hand in hand.
Yeah,
in some sense.
Exactly, because that is what makes the environment safe to make mistakes in and to play around in. But yeah, that's exactly the thing. Like the tool call permissions do not belong into the agent harness. Like everybody who uses agents has turned permissions off, basically. So why is that? Because for agents to be useful, you want them to do things, and permissions are like the opposite of that. They exist to prevent the agents from doing things. But ideally, you run the agent in an environment where it cannot do destructive things. Like, yes, let it connect to the production database, but as a user that only has read-only access. That's fine. Or maybe not to the transaction database, but to the analytical database. So all of this has
read
to
from replica.
Exactly. So things like that. So these are all things that need to be baked into the environment, and that's the hard part. Like figuring, like giving access to things is such an annoying problem to have.
It's an annoying problem, yes.
I'm sure you know that from your own work as a human. The amount of times you have to log into a system today, it's crazy. Like half of your day is spent logging into things, and then the next day again because the session expired, and then that takes the joy out of work, and that's also what makes it difficult to provide actual environments in which the agents can do effective work, which is why we all run them on our laptops at the moment. But because
we are logged into systems, we have things set up.
We have things set up, and now we see a proliferation of startups that offer you sandboxes on demand. I think like every major cloud provider has an offering for this now. Say Modal and Cloudflare sandboxes and a gazillion sandbox providers specifically for agents. Most of them are still based around the notion of like ephemeral environments. Like I have a task, I want to run an agent to in an environment specifically only for that task. And that works reasonably well for a wide range of tasks, but I think...
But your local host is not ephemeral,
Exactly.
Right?
I think once we have had enough of that and explored that enough, we'll come back to a point where people want at least a handful of developer laptops on the cloud, so to speak, where everything is set up, where all the tools are in place, where when you make a change, the change stays and doesn't like magically disappear. And it's just like, it's a machine in the cloud. It runs until you turn it off. And that's very easy to reason about, and makes a lot of things easier, because like with sandboxes, that maybe the devil's advocate will tell you, but that forces you to describe every little part of your software system so that you can get it to run in a fresh environment. That's a good property of your project, that your project should have, so your project actually benefits from going through this pain. Yes, that's true. It's also still painful. And
but you still want to play around with things, right?
Yeah.
You need to combine the best of both worlds.
Yeah, because there is a, like, I guess the best example for this is like research tasks. When you get 5 customer support emails, you want 5 initial investigations, and you don't care about where they run, how they run. Basically, you just want it to be the latest deployed version, so that you know you're talking about the same thing, or like researching the right code, so to speak. But that's it. And for stuff like this, ephemeral environments, great. That's exactly what you want them for. But for feature development work, I think we have everything set up, and it's just in place, and it just works, and you don't need to log in again, and you don't need to send a million secrets somewhere. And if you want to play around with a crazy dev tool that somebody came up with, or build your own dev tool, then it's nice to...
You want a good base, but then you want to play around with that.
Yeah, so...
And the base should be repeatable,
yeah,
and then you want to play around with it.
Yeah. So in my mind, it's like, okay, I want to have my developer laptop in the cloud, and then I want to have a lot of like cattle style.
And then you want to play
machines.
around it from your laptop or from your phone.
Yeah.
Right. That's where it kind of continues.
Yeah, because then like, okay, once I have that laptop in the cloud, then I want to remote control it, and then then suddenly you find yourself installing SSH clients on your phone, and then yeah.
And about the persistent, maybe for those who listen to also check out different interesting products. So there's Fly Sprites, and the other one you mentioned.
Yeah, so the creator of Tailscale, if you aren't using Tailscale, you should be using Tailscale. It's amazing.
Tell quickly for the audience what Tailscale is.
So Tailscale creates a virtual network between computers. So if you install Tailscale on your server and on your phone and on your laptop, all of these 3 machines can talk directly to each other, no matter what other network connections
in a private network.
In private, exactly. So
they have SSH keys?
They have WireGuard cryptographic. It's complicated, but point being is Tailscale makes sure that all of your devices are discoverable to each other and not accessible from the outside.
So securely talking
it's
to
secure
each
and it's easy.
Nice.
And
you use it?
I use it a lot because that means when you develop small services for a small group of people, like your team at work or your family, or just yourself with your different devices, you can completely remove the authentication and identification layer because it's just a header. It's just available. You just know who the person is or what device it is. And then suddenly you realize how much easier it becomes to develop like throwaway software or prototypes or like very specific tools that serve a single use case, because you just don't have to worry about all of the annoying bits that you need to do when you build a product, and no OAuth, no user database. And
have you used Tailscale in production or not really? It's
like we don't have a use, like we use it internally in our team, like to share services between each other, but
tell me, how do you use it?
So right now we have it hooked up to our like background agents that we're developing right now, so that if somebody spins up a background agent and makes a change there and spins up AMP there, I can access this because as long as I'm logged into Tailscale, So
Okay, so you share pretty much the same Tailscale network.
like all of our sandboxes, they join the same Tailscale network. All of our people
and you
in
can
our team are in the
quickly
team.
share with each other.
And then I can immediately access the machine. It's because it's on a network layer. So
I will make a note and
yeah, it's amazing.
think if it's applicable in Pactum.
I didn't install it for the longest time, but I heard so much about it, and when I
Yes.
installed it, I finally understood. Oh yeah, okay, this like.
I actually saw Tailscale founders in AI Engineer in Paris.
Oh, nice,
Yeah,
nice.
They were there.
Yeah, actually, one of the founders now has his new company called Exe, like Execute.dev.
Oh, so that's another
yeah,
service.
that's it. Yeah, exactly. That's another service.
Let's talk about it. So
yeah. So this is another service that gives you the persistent environment. So by default, you can create, I think, 25 virtual machines. They all share the same resource pool, but it's just so easy to spin up a new machine. And then Exe takes care of authentication. So by default, the machine is not accessible to the general public. It's still available on the internet, but you need to log in, and Exe takes care of all of that. But they also have an agent running on that machine. They built their own coding agent called Shelly. It is available on the machine, has a web interface. So what you can do is you create a new virtual machine. It's one click in their dashboard. And then another click takes you to the agent.
Yeah.
And you say what you want.
From that machine.
Build me a fitness tracker for my workouts or whatever.
And we'll do everything.
5 minutes later, you have that, and it's available on the internet, but only for you.
Oh, nice. Wow.
Yeah, and then there is no deploy step.
How come it's available on internet and only for you? Technically, what do you mean?
You need, like, if you do this from your laptop and then you want to use it on your phone, you visit the website.
Okay.
You get like a subdomain. You go there, and then it says, enter your email, and then you get a verification email.
Okay.
And then you need to do
this
this once.
They just do
and
the
then,
auth and then.
Yeah. And that is such a powerful thing. Which again, you kind of need to experience because it's a special feeling to make changes enter life instantly. There is no deployment pipeline because you're touching the running system.
Yeah, playing around with it in real time.
Yeah, exactly. So like, especially for prototyping, this is great. And
cool.
It reminds me a bit of like the ideas in Erlang, like Joe Armstrong, who is unfortunately no longer with us. He, like Erlang is built around these long-running processes, actors, and so on, message passing, and
that's where Go got the idea for routines and for channels.
Yeah, and the interesting bit that like Joe Armstrong was doing with it, the creator of Erlang, was that he would have so-called generic servers running, which upon receiving a specific message would adjust their behavior at runtime. It's like, now I turn into this. Kind of like stem cells, They have so it
was adapting in real time.
Yeah. So, and it's amazing that like what this technology can do, and that has been around since the 80s. It's just never turned mainstream. But, so there are a lot of good ideas in there.
So for people to check out Fly Sprites, and it's fly.io, right?
Yeah.
The service, yeah. I heard, by the way, very good things about Fly.
Yeah.
And you know what I love about Fly? Their engineering blog
Yes.
posts. They're the best. No bullshit, just very good, straight to the point. I love them. Like,
I think it's even just Sprites.dev.
Sprites.dev, yes. Sprites.dev.
So Sprites does a similar thing, gives you an API call, and then through the CLI, you get like a VM in the cloud.
Persistent, not ephemeral.
Yeah, persistent disk. Yeah. The VM itself is ephemeral, but the disk is persistent. And I think
which is what you need, right?
Like, and I think they snapshot the VM state, so it gives you the illusion of being completely persistent, and it's very good at giving that illusion. So that's also pretty cool. All of the like popular coding harnesses come pre-installed there. It's just it's a new form factor. So people are still trying to figure out like where this would be useful, because we're so used to like stateless things that now stateful things are useful. In fact, a lot of the things that are really useful are stateful.
Yes,
like
absolutely.
your database. You want your database to be stateful.
Yeah, I was just talking about impact about, we have platform components and some of them are stateless. But we want now to have some stateful components. And this is where the hard parts become, because then you have to think about modeling and this and that.
Yeah.
But this is where all the business value is actually.
Exactly. And that's like I feel like collectively as a profession, at least regarding web applications, which arguably make up the largest part of app in terms of like market share, because it's like the web is an amazing platform. We've kind of like collectively resigned and said, state, not for me, but it's more like a religion almost. Whereas every game developer is like really good at managing state because that's their bread and butter.
I don't know. I was at I tasted the world of stateless, what was it, cloud stateless functions. And I didn't like it. I used AWS serverless, the serverless motion. And like all the idea, now let's have like 30 different serverless functions and stuff. I don't know, it didn't work, at least in where I tried it. And for obvious reasons, like things were still interconnecting to each other. And in the end, you still have like your database will be, your scaling bottleneck and things. So the illusion of infinite scalability is just an illusion, because you will have bottleneck in other places. And,
I think the most interesting things in that space right now to check out and play around with are Cloudflare's durable objects, or even better, Rivet.
Rivet?
Rivet. Rivet.dev. They also give you, and they only do that one thing. They also give you stateful actors. And you're like, hey, what's an actor? Why is it stateful? Why should I care? If you, I'm sure you've had this problem with Pactum. You have your n stateless web server instances. And then you want to do something outside of the request response cycle. So you introduce a job queue, and then you have worker processes that pop up stuff off the job queue, but where do the worker processes run? And you have to figure this out over and over again. So what's interesting about actors as implemented by Rivet or Cloudflare Durable Objects is that they offer the following. We give you stateful persistent computation. So it doesn't matter which backend instance the user hits. That instance can still be stateless, and all of the instances can hit the actor running in the Rivet cloud or in the Cloudflare cloud. And Rivet or Cloudflare take care of making sure that all of the requests end up in the same place, no matter where they come from. And then the actor itself has a log of state changes. So even though when it's put to sleep and rehydrated, so to speak, it still has the same in-memory state. There are some rules you need to follow, but basically that's the deal. And also they often give you like a SQLite database attached for free. And that allows for like interesting module boundaries, because you can say like I spread out my computation, I spread out my persistence across the entities that actually change. Because if you think about it, in many cases, yes, we put everything into the same database, but the consistency boundary doesn't have to be the entire world. And actors allow you to leverage this fact very easily.
Now, by the way, I think it's a good segue to another topic. So we discussed pretty much the infrastructure for agents and the sandbox and running in sandbox, running in cloud. And maybe it's a good segue to discuss the kind of microservices versus monorepo, polyrepo, and how to organize your things, which would be conducive to agents and to humans. And again, sometimes like some truths are still true today, nothing changed, but maybe something's changed, I don't know. For example, I think there is a company called NX. They specialize in kind of helping you with monorepo deployments and stuff. And they did, and again, anecdotal, but it seems there is a pattern where some people in the industry, there's no proof of course, but some people in the industry see that agent operates much better in the monorepo than in the polyrepo environments, where you need, again, for one logical change, like have 3 PRs and there's no clear way even like how to test it all end to end. and again, it makes sense, but I wonder what's, probably you thought deeply about it as well. Like, what's your experience? What do you think about this topic? Yes, because like even at Pactum, we did have some, well, not only because of agents, but what we see is that, and I mean, I made a presentation today about it, like why it's always a bad idea to split too early, right? Especially for any logical, cohesive change.
Yeah.
You want it to be in one place. You want it to be one PR, and you want to have the feedback loop in the same, ideally PR. But I wonder what's your
I mean, you
experience?
summed it up pretty nicely already, essentially. Like I think it was Uncle Bob, maybe it was Sandy Metz, but the question of where should you place things is always a difficult one. I don't mean like in which file in the code base, but in which like logical module, like where are the module boundaries? What does a module boundary mean?
Yes.
So, and the best heuristic I've heard from one of these two people was that things that change for the same reason should live in the same place.
Yeah, it's called change locality.
Yeah, and if you don't know, the safer bet is to assume that everything changes together. And then by putting it all into one repo, you just eliminate all of the barriers for finding those things and making the change in a coordinated manner. So in terms of microservices, super overloaded term, everybody has a different interpretation of it. I think like my rule of thumb is, can this service ever be done? Like, is the scope bounded? Then yes, maybe having it as a separate thing makes sense, but there's rarely business functionality. So for example, if you have a thing that needs to resize images, classic example of like services you would use if you're building an application. There's an image service. You want to upload images directly to it. You want that service to like resize them so you get thumbnails. You want that service to run metadata analysis. You want that service to like store everything nicely for you. It makes it easy to access. Maybe you want like automatic expiration, but we're already like running out of features that we can think of. And most importantly, it's a generally useful thing. And since it has specific storage requirements, it even makes sense to have the network boundary in place and pay the cost of it being a separate deployable unit. That's a microservice in my mind that makes sense. Splitting, I don't know, commenting functionality in your product into a separate deployed service makes no sense.
Sounds like a bad idea.
Because sounds like a bad idea. It's a thing people have done. And because you can have the same well-defined model and well-defined boundary within one process. There is nothing that says you need to have the network in between.
The way I'm reasoning about it is that, I mean, let's say you start a startup just from the beginning, and let's say you're operating in a semi-known domain, or you're not too sure about the domain. Like, you should never start with microservices. I would say the only reason, I'll maybe even give an example of who can afford to start with microservices. Just to give a very extreme example and saying like why you probably are not that. And that's, for example, I mean, let's take Estonian startup scene. There's Wise, ex-Wisers started Lightyear, right? They worked in fintech for 10 years. Lightyear is doing trading, right? Financial trading. This is the industry and the domain that has been known for like decades, right?
Yeah.
The domain is known. You know that you have a treasury, you have FX risk, you have this, you have that, and you know that this will be true today and in next 10 years. And maybe you already know, because you're B2C, business to customer, you will have these scaling problems like in pretty much immediately. So maybe in this situation, when you know your domain really, really well, like really well, I mean, you can afford to start and split things already from the start because you're so sure. Your confidence level is pretty much high, very high. In other cases, pretty much everyone else never start with microservices. Like, always start with one repository, and then people are like, oh, but it turns into big ball of mud. No, well, you keep in discovering your module boundaries and your bounding context and your APIs between components inside one process, right? Inside one service. But what is most important, you have you can do end-to-end refactoring with one PR from data model to API and to UI with one PR. And that's very powerful because you reduce the friction for yourself to iterate on your model. Because sometimes what happens is that people have messy model, they move something away, and they never refactor the model because it's so hard if it crosses the network boundaries, and especially if it's in different repositories. Now you have to think about API, about the versioning, and again, this is fine if you really have to have these things, but when the boundaries are not clear, then you will have very chatty modules having very messy API between themselves that you will not get right, and you don't have a high cohesion. You don't have you will have high coupling, very low cohesion. And that's bad. But anyway, this is the primer on this from my side.
What I wish to see more of and also do more of myself. I've only done it like as part of my side business, but deploying vertical slices per customer. So that you have the entire application, it's the same application that everybody runs. But if you think about it, most applications, in terms of data and everything, they have like some concept of organization.
Yes.
Every user needs to belong to an organization, and things that happen in one organization do not affect things happening in another organization. So why don't you just give every organization its own compute?
It's like single-tenant.
Like your application is single-tenant, and you just deploy one instance per tenant.
With its own database and everything.
And then in the little bit of practice I have with that, two things stand out. So first of all, the data volume shrinks. And it shrinks so much that it opens up more technological choices that lead to further simplification.
So pretty much you do sharding from the start. Kind of,
Exactly. But
like
when you say sharding, it's still like, but every layer is stateless.
But you have everything separate.
You just have everything separate. The light version of doing that is like every customer gets their own database, and you just route through the database, but it's rarely just the database. You know, like it's all of the other attached services.
This is actually how we operated and ran it in Better Medicine. Still in medical tech, running things in the hospitals. So pretty much you have CI/CD pipeline, but I mean you have same software, but you deploy it into separate instances.
What is your experience with that? Because I haven't talked to anybody who has actually done it. And
I mean, in our case, it was a necessity. Like you have no way around it because we dealt with sensitive data, and you have to do it. So we had to run certain things. Long story short, it's like pseudonymization process, but TLDR is that you don't want sensitive data to leave the hospital, so you have compute there pretty much. I mean, it worked, and the whole idea is that, well, you agree with the hospital so that you can run your CI/CD pipeline. That's the most important thing. Like that's the battle you want to win. That you have CI/CD established feedback loops, and you can, I mean, patch and update things on demand anytime, so that you don't ask someone from the hospital and say, "Hey, please, could you update?" That's not 1990s, but that's the most important thing. And then, of course, like it's painful in the beginning to set it up, but once you have it, you have it. But I would say, let's say, it's even more interesting for cases where you're not forced to do it, but you might decide to do it because of the benefits it gives you.
And I think like again, there's just not enough experience with that. But and the beauty of agents is that it's much easier to try this out nowadays. And like if I look back at all of the problems I've seen through my career, a large part of those problems comes from having to work through huge amounts of data, making sure that things don't touch things they're not supposed to touch. Making sure things are still snappy, and then it's like, you know, you start to introduce caches and read models and denormalize data and all of that.
And maybe that will go away if you short.
It of course it goes away. Like if you have like like the average customer doesn't have a lot of data, yet they need to pay the price of everybody's data being in one place. So you as an engineering team have to like optimize a lot for this very strange case. Whereas if you split it by tenant, the complete deployment, maybe you have somebody with a lot of data before you even start changing the code. You can literally just put them on a bigger instance. Yes. And the other thing which is really nice about this is when you deploy a product on the web, you have customers everywhere.
And you can put it on the edge where they are, right?
Yeah, and like there is no thing as like, let me run that cron job at night, because it's always night somewhere, but it's also always day somewhere. But if you scope it to individual tenants, well, that tenant has a day-night cycle that you can predict.
And you can actually like do your maintenance work at night.
Exactly.
If you want. Yeah, that's very interesting. Yeah, I haven't thought about that. Yeah.
So I see like more benefits than drawbacks. Maybe the only drawback is that we've kind of like collectively forgotten how to do this.
Yeah, but I think given all the new infrastructure primitives, now it's probably more easier than ever in history to do it.
Yeah, exactly. Because the main problem you need to solve is how do I update all of these instances, and you know, like I run, you know, you have to run like 20,000 deployments, and it's like, honestly, it sounds like a thing that has been solved many times, because the shape of that problem is always the same. So it can, you know, there is a very popular solution whose name starts with a K, which was developed specifically for this problem. So that's where I would start looking for a solution to this problem. Chances are people are already using it. So.
By the way, about maybe going to another one, another topic, but open source and build versus buy. And what's your opinion on all of this? I mean, there's so much to untangle. We can go to supply chain attacks, but maybe let's leave the security aside maybe for now. But like the whole economy of, let's say, open source and build versus buy, how does it shift? How do you think about
it? I mean, maybe let's start with what is open source.
What is? I mean, you tell me.
Okay. I think when most people talk about open source, they mean like anybody can contribute to any project, which is nice, but actually not really required. Like if you publish code today, you don't owe anybody that you'll merge their changes or even look at their change requests. That's why you have forking and licenses. So but the expectation is that open source projects have maintainers who care and who critically evaluate every potential submission, which, like all of the projects that are open to that, they're drowning in slop. And now the solution implemented by projects like Pi, the coding agent, and Ghosty, is to just keep a list of trustworthy people, to put a little bit of a barrier in. It's like, hey, you need to, you know, all pull requests are auto-closed. Unless you're on the list. Here's how you get on the list, and to get on the list you just need to join Discord and say like, hey, I'm a normal, you know, like
just at least the first barrier.
That's the first barrier. Exactly. And if you cannot even do that, then you're probably not interested in following up on your changes. Or maybe
you're open flow agent.
Exactly. And which is a good point to like, maybe it's good that it's hard to log into things.
But we will solve that.
So again, it depends on where you are in your business. Obviously, you don't want to write your own HTTP library. You don't want to write your own JSON parser.
Or security primitive libraries.
Or security primitives. On the other hand, you know, it's like half a day of work to do both of these things nowadays. So
I still want to do security primitives.
I mean, you don't want to roll your own crypto primitives for sure, but usually those come with the programming language. So it's not like you have. I mean, you could, but you have to actively go out of your way to roll them yourself. So, but in many cases, it is more useful to own the library yourself, because you can change it, and often you only use like a subset of the features provided by the piece of software.
That's true. So in some sense, you don't have to worry about the cost. But wait, what if the main branch develops further, and now I want to merge back? You pretty much burn that path, and you say, well, if that happens and there's a new feature, I'll ask my agent to integrate it into.
Yeah, or just write your own library
Mhm.
like that copies the existing library,
Mhm.
but only the 20% you actually use.
Mhm.
Because every feature that exists in a piece of software
Mhm.
is like you pay the cost for it.
Yeah.
You pay the cost
It's
for
pretty.
it
It's a dependency cost.
in lost optimization opportunities. The interfaces become wider
Yeah.
to accommodate more use cases, which you might not have.
Yeah.
Um,
So pretty much the idea is like fork, not even fork, like copy and trim to your needs, right?
yeah,
Yeah.
yeah. Like say,
Mhm.
pick a basic idea, and I feel like copying software is a skill.
Mhm.
Like I have a few of those projects
Yeah.
right now. I'm copying Tmux
Mhm.
because I want a version of Tmux that runs on Windows. Not that
Mhm.
I don't even use Windows. I just
Mhm.
like, and it's fun to copy things. But there is a skill in like figuring out how
True.
to copy software and what to take and what to not take. And
I would say there's even a skill to inherit. There is a skill to get. Let's take the classical open source. You take some library and how to integrate it into your system. Because what sometimes people do, they just integrate it and they don't create a facade of their own API. They just go and use the API of the library. But then they say, oh, wait a minute, we have a major update and it has cool features. Cool, I want to use those features. But now all my API got changed and I have to change it in 1,000 places in my code base across the board because API changed or something. So sometimes I think simple things like creating your own facade or still having a control that if you update the library to the major version, maybe you don't have to propagate it across all your change and you just like do the change in your adapter once or facade once.
Depends.
That depends, yes, I agree.
Yeah, like I used to do that a lot.
I wouldn't do it for, let's say, Zod or something.
Yeah.
But I would do it for, let me even think, some auth library or integrations or... it depends where, yes.
It depends where exactly.
Depends
It's like
where.
I think every programmer who's been around long enough has gone through a phase where they put everything behind a facade, and then
True.
the big lesson for me here was actually Go and Go's type system, because it's together with TypeScript, it's the only type system that gives you structural typing, which is essentially like duck typing checked by the compiler, which is very useful, but not very widespread. Go implemented it on purpose, TypeScript out of necessity, but
I love that Go implemented it on purpose.
And when you start thinking about it, it forces this very nice property, which is unlike Java interfaces where people learn about interfaces for the first time usually, that you can define your interfaces with like where the consumer lives.
Yes.
And that is actually where the interface should live.
Yes.
And in Java, you then need this specific like glue layer that says like this interface and this package is actually implemented, even though the shape is exactly the same.
And this compile time implements this is actually bad.
Yes.
Yes, it's actually bad. It's not good.
Yeah, because like when you need something to do your job, you just want to say like, I need a thing that can, make an HTTP request. And you don't care about what that thing is as long as it behaves the right way.
As long as it quacks like a dog or whatever.
Exactly. But that means like interfaces belong into, like the definitions belong to where.
Who owns the definition? Right? Who owns
the definition is owned by the consumer.
Yeah.
And that is what is missing in many cases when you start building these facades. Because you just look at what the library can do. And then you make a smaller version of that, and then you look at your program and use that smaller version, whereas you should look at what does my program need to do, express that,
and then implement it.
And then implement it through some library. And usually you want to do that in cases where you expect change, either because you don't know yet, like maybe you want to abstract over the database because you don't know yet which, it's like SQLite or DuckDB or Postgres.
And you just go with repo interface, right? And the service layer. And you just
repo interfaces are also bad.
Let's talk about it. Why? I mean, it depends, right? What's your
when you say repo interface or repository implementations, what I see in my head is like you have a class or an interface that defines every single data operation.
No. Okay. What I mean is that, for example, what I mean is that very thin and only necessary layer of the operations that you need that are very specific. For example, find user by ID, right? And you need that. Or, okay, I'm not talking about the auto-generated repo interfaces in some languages like Spring. Like I don't know, when I programmed at least Go, I used to generate like by hand, right? Write interface, user repository, and then only define operations. And then I wrote SQL queries for those operations.
But that's still.
Yeah.
This interface can only ever grow.
True. It's not. But then, okay.
So,
but then let's discuss the software design. So yeah, how would you access your
and this is
data?
what makes Go so nice. So what you would do, or what I would do in Go, and this is what I mean by like interfaces should live with their consumers, is let's say you have let's do command objects. You have a command object here, like a struct with an execute function.
You define a thin thing
and this thing needs to, you want it to send a welcome email or some kind of transactional email to a user. So you need to look up the user by ID and you need to send an email. With like a template and template data. So this file will just say, I need a thing.
Yeah, a thin
that has a find user method.
Yeah.
And then you have maybe some other operation that needs a delete user method, whatever. And that would be defined in an interface that has a single method, delete user by ID.
So interface segregation principle, right?
Yeah, and then you would have a single object that actually implements both.
Yes.
Yeah. But I would never make the interface like one interface that.
Yeah.
Because then every time you want to implement that interface, you have to implement like 50, 60, 70, 80.
And there, with dependency injection, you can literally pass the same object.
Exactly.
For example, in your main or bootstrap, into different interface declarations which are owned by the use case.
Yes.
And that's the true inversion of
and that's how it should work. And it works like that in Go and it works like that in TypeScript. And then it can work
and it doesn't work like that in Java.
Exactly.
And that's
then
bad.
in Java, you can do that, but then you end up with like all of these useless implementations in like where you actually wire up things.
I love that we bashed Java. Feels good.
I haven't published the experiment. Maybe I should. But I like the ergonomics of bun. And then just for fun, I thought like, what if Java had the same ergonomics as bun? So I made my own little bun like tool, which could fully parse Java and gives you like Godog, but for Java, like on the command line, and gives you like Go ergonomics and bun ergonomics, which is essentially the same, but for Java. And then I had my agent write Java, and then I was so surprised that if you actually say like, I only care about the most modern version of Java, nothing else, that Java is full of really good ideas and implementations now. Like it has basically functional reactive programming built into the language now. It has like records and pattern matching and like it's actually pretty decent. For some reason, it doesn't have JSON parsing in the standard library, but so be it. But with this like tool I built, it's just like one command add, like npm add, but for Java, and it just pulls the jar and then.
By the way, what bun? And I know we are digressing, but we can afford it. My podcast, I do whatever I want. No. But the quick digression for the bun, because many people here who will listen to it use Node.js and TypeScript stack. Yeah. My assumption, I might be wrong. Bun is relatively new thing, right? But there's been an investment into Bun. Who acquired Bun? I forgot. Anthropic, exactly. Yeah. Small company, Anthropic.
You might have heard of it, yeah.
Yes. But what are the core things where Bun excels compared to Node.js? And what is the promise of Bun?
Yeah, so...
Promise.
Yeah. So I guess the philosophy is a bit... It's just different philosophy, essentially. Okay. So...
I haven't used Bun, by the way.
Okay, you should. So Bun is obsessed with performance and developer ergonomics. So basically the idea is that if there is an action you need to take in your application while developing it, more than once, it's a common action, Bun can do it.
Okay.
So
for example?
Adding a dependency to a project. You can do bun add. You don't have node and npm. Bun add will go to the npm registry and download the package from there, but it is one thing. Then bun natively can execute TypeScript without checking the types, but hey, it can execute it because that eliminates the compilation step, which is a very common thing in JavaScript/TypeScript projects.
And so also increases the feedback loop, right?
It
and
makes the
also good
feedback
for
loop
agents.
faster, yes.
Okay.
And
so guys, check out Bun.
yeah, so basically every little thing that comes up very often ships with Bun.
And I think it's very logical for some companies to swap Node.js with Bun. I mean, there might be
it's a drop-in replacement for you in most. Like, of course, there are some differences that you'll find out when you run it on a Node.js and then suddenly you run it on the Bun and it fails at runtime. But
noob question: are they on V1? Is it stable API and Inference?
yeah, they're like on version 1.3.11 or
so
something like that. Like,
good.
And everything that's like Bun specific lives on a Bun object. But they have like a very ergonomic web server in there, so that you don't need Express or something like that.
Okay. Cool.
They allow you to ship single file executables cross-platform. You can actually build, it's like Go ergonomics. You can say, hey, I have my application here, and then you say bun build, and it will spit out a Windows binary, a Linux binary, a Mac binary that you can just send to your end users, and then it just works. And what it does, it bundles the runtime plus your application code. You can embed static assets. Like it's basically Go, but with JavaScript.
Yeah, got it.
So,
fun topic, OpenClaw. Have you tried, or what do you think about it? Have you tried it for your personal stuff? Have you sandboxed it somehow? I don't know. Just curious.
In April last year, I had this vision that I want to speak into my phone and it transfers money. Because I have too many like random invoices I get every month, and I was always late with paying them because logging into systems again it's just too much. I don't want to.
Do you know? I can tell you one joke, by the way, for you to be aware of the security risk. So we have a person from Pactum who wrote their optimization, an agent who checked the email, checked the invoices, and then made payments. And then another colleague, for fun, sent their Telia invoice to them. And I don't know, like, I won't try to, maybe I'm messing up the story, but the idea is that probably the agent tried to pay it, but then there was like some confusion, and the person got a call from Telia saying, hey, is it the right payment or something? But anyway, so be aware that someone might email you their invoice.
Yeah, but it's like, I mean, that's obvious in that sense. Like so I had that vision, but I didn't have the time to like actually implement it. And then a year later, OpenClaw happened, and it's like, damn.
Have you tried to do it with OpenClaw? I think
I haven't used OpenClaw directly because it's like if you're already working, like the value of OpenClaw is that they have built all of the integrations. That I have thought a bit about, like the model. It's a package product. That's what makes OpenClaw great. But I already had my own thing, so like I don't need all of the integrations. Telegram is enough.
Do you have your own agent in Telegram?
Yeah, I do. I need to. I'm not using it that much because I need to still figure out the like logging into my bank thing again without it expiring and accessing my email and so on. So, unfortunately, not like Google makes it really hard to access your own emails, and then.
What are your actions you do with your personal assistant today, if I may ask?
So I need to fix the payments because I didn't make it ergonomic enough for the agent, but I have made a few payments. Mostly it's so I have like invoices in Sweden and invoices for various like things here, and for some reason it's difficult to make automated payments. So actually Wise is the only bank or financial service provider that allows private individuals to use an API.
I'm proud of it because I started and developed public API of Wise.
Really? Oh, nice.
I mean, not in its current form, but 10 years ago, yes.
But it's like literally nobody else has that. And so when I found that, I said, great, let me like integrate that. And then by default, you cannot actually confirm the payment, but just like reading the emails, extracting the information, and preparing the payments.
Yeah, preparing the payment, exactly.
And then you just need to like confirm once in the app.
Yeah, perfect.
That eliminates so much mental friction. That's incredible. And then I wanted to do the same thing for LHV, but I ended up just... that's another thing. You can tell an agent, not that I have done that, but you can tell an agent to use a browser, log into your LHV online bank, record all the requests, and then write code that makes the same requests, so that you can have an agent do the same thing through a command line interface.
True.
And then you can tell your agent, hey, do this. You still get the smart ID pop up, and it's all, like...
What do you believe is the future of interfaces of products? Because do you believe everything will be agentic native? And let's say whatever model anyone will use, it will have access to all the tools of all the product offerings?
Let me answer with a question. Why do you leave Slack?
Why do I leave Slack?
Yeah. Like you're in Slack talking to a colleague or posting a channel, and then you leave Slack. Why do you leave Slack?
Well, for example, the last time I left Slack, I was preparing a presentation, I was using Excalibur tool, right? So it's a graphical tool, and I wanted actually... by the way, I still sometimes use Cloud, and Cloud has access to Excalibur, and it actually, by the way, sometimes produces pretty good graphs. Sometimes I want to do it myself, so for example, this.
Yeah, but if you saw that same application in the sidebar in Slack, would you still leave Slack?
Probably no.
Yeah. So for certain types of interactions, it's nice to have a high fidelity graphical user interface. But the more it's integrated with the place where you spend most of your time, and for most people it's Slack at work, the more valuable it becomes.
True.
So if Slack had that functionality, you wouldn't go to Excalibur. So, because then what is the outcome of preparing that presentation? You're going to share it on Slack. Or like you're going to tell people about you giving a presentation in 24 hours or whatever in Slack. So most of the interactions in your day-to-day works, like gather information, synthesize an action, take the action, and tell everybody that you have taken the action, and then repeat. So the only step that's outside of Slack right now is like actually doing the thing, like actually making the presentation. Now with agents, you can have that step triggered from within Slack, and you can have it report the result back to you in Slack. And with MCP, like Slack should do this. They should already support like MCP apps, because MCP servers can now ship single-page applications that are displayed inline, in Claude, in Codex.
Has someone implemented, let's say, this new spec?
There were something that I think Shopify uses it for their like storefront. So this allows you to like never leave the place, which is great. It's just like there are so many things and there's not enough attention.
So we will have again the area of micro front end and stateful components, where pretty much there are things that will not require front end. Then it's just input output and context and the tool calling. You can have it in Cloud Chat or Slack Chat, wherever you are. But for some things that would even require the front end, it can pretty much pop out only the part that you need with this context, which is stateful, and then you do the action and it disappears pretty much.
Yeah. And that's in itself, you're like, oh, but you've just described opening a new tab in the browser. Why is that special?
No, but still, the feedback loops can be so much faster.
They can be faster. The important bit is that, especially when Slack is moving there. Slackbot is an actual AI agent now. I don't know whether you've noticed, but I was so used to Slackbot being useless that I almost missed the fact that now you can, like, it works as an agent.
Okay.
And it's actually super useful. Like, you can ask it, like, when did I talk to this person about that?
By the way, we did deploy our own Slackbots, like agents inside Slack. So nice. we now have Ralph, and that's the agent that has access to all our production logs, to Sentry errors, to code base. So the first triaging of the error usually is through Ralph in Slack. And nice. People ask a lot of questions from Ralph. And another bot that we implemented is Pascal, and that has access to all our data analytics. So you can just, hey, at Pascal, tell me how many customers we have and the breakdown.
Exactly, that's a perfect example of
so we have it
UI going away, because in the past you would ask a colleague who knows the data structures and so on, and to run the analytics query, and then, but what does that person do? They get a ping, hey, can you tell me? And then they go and work their magic, and then they, taking the action outside of Slack, and then they go back and say, hey, this is the result you asked for.
Yeah. But how do you think, okay, so that's clear.
But to close the loop, where it gets really interesting is when you talk, like, think of the ChatGPT app or the Claude Desktop app, when you integrate multiple data sources.
Mm-hmm.
Because then what you can do is when you have your email and your calendar integrated, not just read only, but like read and write, you can ask the agent, send an email to Vitali proposing a time to meet based on my schedule.
Yeah.
And it will figure out, oh, I need to look at your calendar
Yeah.
and see when you're available.
It has all the context, all the tools.
Exactly. It has all the context and all the tools. And that becomes really interesting then when you combine it with other data sources that are
By the way,
related. And then
this is how we see it in Pactum, like, and we started kind of even earlier than others because we started in pre-LLM era, like figuring out autonomous negotiations before LLMs existed. But what I'm getting into is that the real hard part is to have robust commercial decisioning at scale. And what you need there, though, you need a trust layer. You need almost like, you need to understand which actions, and is there a almost like deterministic space where you operate that whatever action you do there is acceptable, and then you just optimize in that space. And wherever you're in the danger zone and you're not sure, you have a human in the loop.
Yeah.
But why I'm saying it, like, do you see that those interfaces will be optimized for the fact that whenever human in the loop is needed for confirmation, this will become very seamless. And pretty much this confirmation will happen either on Slack, or if you're on the phone, you'll literally have a pop-up on the phone, or there will be like this confirmation will be as smooth as possible. And
of course, I mean, that's the ideal state. I think we just haven't had enough experimentation around that. So in the example you just gave me, the ideal flow is you already have Slack as the human. And the harness or the model itself, or both, depending on how you structure it, knows when and how to escalate to a human. Basically, like ask human is a tool available to the model. And you have something monitoring the state of the contract, so to speak, or of the negotiation. And if it heads off into like danger territory, then you just escalate manually. But you use Slack as the communication layer because they're already on mobile, they're already connected to everything else, they're already available everywhere. Multimodal, everything is there already. You just need to use it. And most importantly, it's not yet another place somebody has to go to. It's just there. So in an ideal case, that thing would land in a channel pinging a specific person that's responsible for the negotiation. And they can answer right there. They have all of the information they need to make the decision right there. And then things move on.
Maybe a bit segueing into more technical discussion in terms of not even interfaces, but interfaces for using tools. So again, heated debate, CLI versus MCP. And by the way, there was a good article from Hacker News recently, like the person analyzed MCP and CLI. Just TLDR is that, I mean, both are useful in different contexts. And the main benefit of MCP is that it's zero install, right? You just have to have auth handshake and you're done. So it's more sometimes user-friendly in terms of remote deployability if you need usage, because CLI, well, you need the full installation of that. What's your take on that? Where are we heading? Like, do you believe there is a future in MCP, especially if the protocol evolves, as we see now with front-end spec? And do you think the future is kind of that we have both for agent?
I think it's kind of like the same question as asking CLI or HTTP.
Yes.
It's like it's an apples to oranges comparison. Like they serve different purposes. MCP is a standardized delivery mechanism, essentially. So,
but do you think there is something better than MCP? For example, I believe Google has agent-to-agent protocol.
Again, different purpose. Like it's a protocol for getting multiple agents to talk to each other, whereas MCP is.
But sometimes people use it still. People can use MCP for that as well because they expose agent over the tool and then agent talks to agent.
If you want agent-to-agent communication, you can literally just use a file.
Yeah.
Like that is already agent-to-agent communication. In fact, that's what you're doing every day when you start a new instance that has to live with the changes made by the previous agent.
So you think we will have three things, right? MCP for tool calls, agent-to-agent, and CLI again, like, and I agree.
CLIs are just like a different way of doing, like, again, it's just a different delivery mechanism. So like everything you can do with MCP, you can do with a CLI, and kind of vice versa. It's just differently complicated.
Yes.
So in a way, like, I don't know, you use pSQL to talk to your Postgres database through the CLI. Yep, that's making a network connection, and you send data over the network, and you talk to a centralized service. You can do the same thing through MCP. It's just the shape of the thing is different.
What do you think about this whole discussion of token consumption? Like one argument, and again, I don't know if it's true or not. I mean, partially true, right? That MCP in its current state consumes more tokens than CLI. What's your take on it?
That's not true.
It depends on your MCP server,
exactly,
right?
and that's people write bad MCP servers. It's kind of like you write a website; it's really slow because
or you write REST API, but REST API sucks.
Yeah, exactly. It's like you serve a 5 megabyte image on your front page, and then say, "Look, websites are slow.
Yeah,
bad technology. We should go back to
XML.
It's like phone calls or whatever." Like, it's not like if you're new to building websites, you might not have thought about, oh, I actually need to be careful about what I send over the wire. It might make the website slow. And then you make this mistake, and then you learn from it. And we're at that stage with MCP, where people say, oh, MCP is how I connect things to AI. Let me take the REST API exposed by Linear or whatever and dump it straight into the model's context window.
Yeah. I agree with you. I just thought it's interesting discussion because I get that question asked a lot, like, oh, what should we use, like MCP or CLI? I'm like, well, this is like different things. But it's true that sometimes you have a choice, like what to use, but you might use it to optimize for different thing or dimension. So maybe an example.
With CLIs, for example, you don't have to manage the lifecycle of a process.
Yeah.
That's nice. With MCP servers, they're like live things. And then when you have MCP servers deployed over HTTP, very convenient. Pop in a URL, things just work. But again, what works is systems can talk to each other. But the MCP server is actually good. A different story. One space where we've seen a positive example of evolutionary is the browser automation space. So it started with, let me take a snapshot of the page, dumping the full HTML into the context window, and then you take 5 actions.
Chrome MCP, right?
And now it's we only serialize the accessibility tree, and it's like very dense and compact, and just the right amount of information for the model to make a decision, and then.
I played with Cloud plugin for browser. I use it sometimes, but not too much. I don't know. I haven't figured out the use case. I mean, it's useful for example, manual testing or something.
Yeah.
Right? You just connect to your MCP and then you say, go ahead and check it out, like how it looks like. But like for my personal manual use cases, I installed the Cloud plugin. I used it once to play around, but I didn't use it again.
But that's where like Claude runs in your browser? Is that, okay. Yeah,
that's a different.
Yeah, I tried it once and it was terrible, but probably now it's good, but like there's so many things. But I'm thinking more about things like agent browser from Vercel.
Yeah.
That's a very nice and succinct interface that's easy to use for the agent. Could just as well be an MCP. It's just for like remote controlling a process that runs on your machine. It's overkill to start an MCP server. Like you don't win anything by that. But for those use cases, we could see how like people got better at building agentic interfaces, and then whether you deliver them via MCP or via CLI, different story. Like it doesn't matter much. I mean, it depends on the use case.
Yeah, I agree. Maybe a wildcard topic. What do you want listeners to think about? How do you want to stimulate their thinking, given the current crazy age of all the transformations that happen?
I'm sure you've had like a million ideas about, what if we had 100% test coverage? What if we tried this crazy architecture? What if we had this like virtual user testing the application while it's running? Now's the time to try all of this.
Because the cost is low.
The cost is low. It can even be slop, as long as it's just a prototype to test out an idea. Great use of slop. Like just slop it away as long as it's roughly do the thing that you're after.
Because the valuable thing is the cycle time from hypothesis to validation.
So is this even worth building? Does this even work the way I imagine it works? So it's basically like accelerated thinking, where you can look at the result. For doing the actual work, like to create something of quality, of course, delegate the work, not the thinking. Like you should be in charge of what are the module boundaries, how do the subsystems look like. Again, you might use an LLM for that to help you think through the problem, but then it's a very different way of using it. It's like, you can do things like, hey, I want to build this thing. This is the module structure I've come up with. What do you think of this? What problems can you see? And then
this is, by the way, why I mostly like tests, because they help you design the module boundaries. Because you think like, how I'm going to use this module.
Yes, exactly.
What are going to be the inputs, the outputs, preconditions, and dependencies.
Yeah. So that's one thing. And then the other thing is try wild things outside of your comfort zone that you maybe even have only heard about once. Like if you've never done property testing, have the agent walk you through setting up property testing in a very simple toy project.
And you can learn very actively through agents.
Exactly. Right? It's like an infinitely patient tutor that you can use to learn anything. I remember vividly from actually, I think it was November, where I was on a tram and I wondered about how just-in-time compilers work. And I just, on my phone, asked Opus, build me a just-in-time compiler for C, like a subset of C. Because I had a rough understanding of how it should work. And it built one, and it even ran it. And I couldn't believe it ran it because at the time, like Anthropic shipped Sandboxes for like regular Claude already. And you don't even know about that. You can just use it. And I could learn so much from that implementation, but it essentially one-shotted a like traditionally very hard piece of software, so to speak. And then later on you learn that, okay, actually getting a JIT compiler to work and is not that hard. The hard part is getting one to work that's actually useful because it makes the necessary optimizations. But still a lot to learn from that. And I couldn't believe that it can be done in 500 lines of C. And then like it did it in like almost no code. And it's like, oh, that's, that blew my mind. And then you can keep learning or like all of these other things you've heard about. I don't know, maybe you're big on event sourcing, and it's very easy to make all of the mistakes you need to make, or command sourcing.
I still remember that discussion.
Yes, severely underrated.
But
yeah, you can make mistakes much faster now, and that means you can learn much faster. So I guess my message is make more mistakes. With low stakes, please.
With low stakes.
Yeah.
That's great. And maybe to end, what skills, top 5 skills, do you think are useful for engineers to have nowadays?
English. Like.
Yes. Communication skills.
And it's like, but what is communication? It's like concisely articulating your thoughts. Yeah. Like, what is the problem you're trying to solve at the moment? Like, concrete problem statement. Just starting with that is sometimes difficult, but that's important. And then, what do you need to solve that problem? And, so yeah, communication, definitely. Critical thinking, like LLMs produce output that looks plausible, whether it actually makes sense. Well, you need to be smart enough to know that.
And how do you verify quickly, right?
Yeah.
But effectively.
Yeah. And also just getting experience with individual models, like how it feels to work with those models, because they all have different strengths and weaknesses. And like they always try to satisfy you. So the way from which you approach a problem gives you very different answers. Like one of my favorite things is at the end of a session, it's like, would you deploy this to production?
you asked the model?
I asked the model, because usually when you ask it to do something, it's like happy with what it did, and it's like, would you deploy this to production? Absolutely not. Here are like 4 faults with the implementation that would cause critical issues in production.
Yeah. Or, I've seen this. This is a trend now. People say in LinkedIn and everywhere is like, add this to your prompt and your results will be 100x. Codex will review your output. And people say it actually works.
Yeah, that's the problem. Like sometimes, on the face of it, silly things actually work.
Yeah.
But I think it works when you came up with the thing.
Yeah.
Because then you have the necessary context to understand when it works.
Yeah.
And learn like the basics of how agents work. Ideally also like how LLMs work, but at the very least, like what's a context window, what are tool calls, build your own agent, get a feel for what's actually happening under the hood, because this is the new world we're living in. Like, they're not going to go away.
Do you think engineers should talk to users and customers?
Even more. I think engineers need to use the product they're building and should, like, yes, 100%. Like, talk to users, talk to customers, be a user.
Yes, be a user.
Yeah.
That was almost like a rhetorical question, but I think like it's still worth repeating, because, I mean, I like this phrase a lot. Like, what people realize with agentic coding is that in software engineering, coding was never a bottleneck, actually. Now, of course, it got faster, but we still have a bottleneck, which is the product strategy, thinking how to develop further, taste, judgment, and these things don't go away. Linear CEO made a very good post about it in LinkedIn as well. Like, he pretty much wrote it,
Do you know DHH changed his mind on product managers being useless?
No, was it in the latest podcast with the pragmatic?
Probably.
Like okay, tell me.
But basically, for 20 years, he thought product managers are not great. Like, as a function, it's not great to have them, and they experimented with that at 37 Signals.
And he changed.
And it was always not good. And now he changed his mind because, and his analysis of the situation, and I hope I'm not misquoting here, is that because the turnaround time on the engineering side was so long, product managers essentially got bored, and they came up with like they did all of this useless stuff,
generating more stuff into backlog
that we've come to associate with the product manager's work, just because they had to wait for the engineers to get stuff done. And
now actually product discovery is the bottleneck.
Yes.
So bottlenecks moved a bit.
And then he said, like, now he sees the value of product managers because they don't have to wait for the engineers anymore.
It's so interesting. When I reflect, I also don't believe now in engineering over specialization. I don't believe in the fact that now you have like front-end only engineers, back-end only engineers. I think that's a very bad way to organize engineering now. Of course, I just want to say there are exceptions always. You might have over specialization in some specific cases. Like, if you're a big company and your database gets overloaded, maybe you need a database engineer. I don't know. Who knows? But overall, as a default, you want to have very strong end-to-end product engineers and maybe one strong product manager in the team.
Since we're talking about that, I hope we're not like going too much over time.
No, we were wrapping up pretty much.
Oh, okay. Because you hit on one of my other like pet peeves. At a certain scale, everything a company does serves only the company and not the individuals, because it stops being a collection of individuals who like band together in the name of a higher goal, and starts being an organism in its own right, like the individuals are just cells that spring to life and die and whatever by like people come and go in the company, but the company needs to continue existing regardless of when people come and go. So you end up with a lot of structures in place that are great for the survival of the organization, but really not that great on the individual level. No cell in your body likes the immune system, but you like your immune system. So I hope that we're going to see more smaller companies, like more companies in number, and the companies we do see are smaller, because now you can actually get enough done with 10 people or 20 people, or maybe even up to 50 people, to make a difference in the world and earn enough to make a living for everybody involved in this. And you don't need to scale to extremely large sizes anymore.
And you can build great things with it, right? You might build the next Linux.
Yeah, exactly.
And things like that.
Because
you
now
might build the next Git.
We're so empowered that we can do that. Like 10 people is plenty.
As I don't know who said this phrase, but never underestimate the small group of motivated people changing something, because this is the only thing that ever did, right? And I think this gets even more amplified with AI agents.
100%. It's pretty cool. Interesting. Some people say we'll need new economic models, but we'll see how that pans out.
So, as it happens with every guest, we ran successfully over time, but this was great. Thank you, Dario. It was a great pleasure to have you.
Thank you for having me.
Yes.
Great talk.
Thanks. All right, so only pretty much 1 hour, 50 minutes.